also interesting. So this kind of numeral, we call that Arabic numeral. And as I think I shared with you, actually, the Arabs learned from Indians. But the Arabs are merchants, so they kind of travel. They can travel between Asia and Europe. So they actually basically help introduce cultures to each other, different kind of cultures. And so the West, the Europeans actually learned this from the Arab merchants. So that's why they call it Arabic numeral. Arabic numeral is also very interesting is that I think in a way, it's first time we have something called place value. Because if you look at English, one just one, right? Good. Yep. But for Arabic numeral, even though this is a numeral one, but if you put it in different place, now all of a sudden the value change. Now here, this one is 1, but this one actually is 10 in terms of value. Good. Mm-hmm. So in a way, the Arabic numerals themselves are variables because the value varies. It's just that they vary in a specific way. But that's kind of something new, because in other cultures, we don't have that. This actually is kind of unique in a way that we have a numeric system that the numerals change its value depends on where it is. Good. Okay. I think I introduced you to Roman numerals. Roman numerals, this is always 1. This value is fixed. If you want to go 10, you have to use a new symbol, which is X. And if you go to 100, you have to use C. And if you use a million, you have to use M. So each symbol has a fixed value. But for the Arabic numerals, it changes. That's why I have something called place value. Good? Mm-hmm. So we actually playing with values. We just never really thought in that way. When you're in elementary school, we do. Because when we do something like, say, 32 plus, say, 59, what do we do? So normally you say 2 plus 9 is 11, right? Then we say 3 plus 5 is 8, plus 9, plus 1 is 9. Actually, this is 30, this is 50, and this is 10. So to be exactly correct, we actually should say 30 plus 50 plus 10 is equal to 90. Good? Mm-hmm. But we just call that 35 plus 1 is 9, because whatever the numerals, value changes depending on where it is, but we can still play the same. So 3 plus 2 is 5, but 30 plus 20 is also is 50. We still, this part is still 5, right? Good. Yep. So except that this has a value of 5, this has a value of 50. Good. Mm-hmm. So we've been playing with symbols, just like we were not aware of. But now once you get algebra, we actually, that's our main focus, is to go and play the variables, play the symbols. So today we're actually going to use example. We're going to use percentage as example, or as application. So now, first of all, what do we mean by percent? So percent basically is made of 2 words, is percent. So can you guess what that means in this case?
Per 100.
Per 100, exactly. So that means, so when we say 40%, we basically saying is 40 per 100. Good? Okay. That means 40 out of 100. So whatever you get 100 of things. Now, say if you suppose you do a graphing, let's try. We got that. 1, 2, 3, 1, 2, 3, 4, 5. Okay. Let me go.
Whoa. Okay, quick.
Huh?
Hello? Hello?
Hello?
Oh, he's freezing up.
Hello?
Hello? Yeah, he's kind of freezing up. Hello? So anyway, we got 100 of those squares. So when we say 40 out of 100, it's basically we got 40 squares out of 100. Good?
Okay.
So now percent just tell us a ratio between we call part, which is this 40, and the whole. Good?
Okay.
The whole is 100. So basically, that's why we write that as 40 over 100. Top is part, bottom is whole. So this way give us a way to compare things. For example, 2 out of 5 or 3 out of 10, which one is bigger? So what we can do is we change the percent. This one basically the same as 40 over 100, right?
Mm-hmm.
So just times 20 on top and bottom. So 40 out of 100. Now this one, if we make that in bottom into 100, that's 30 out of 100. Of course, 40 out of 100 is definitely bigger than 30 and 100. Good?
Yep.
So now we're going to change it to the same, basically in a way, change the same standard, then we can just compare numbers. So when we write fractions, we could write something different. And how do we compare? One way to do that is turn that to percent. Or if you use calculators, that turn that into decimal. Good?
Okay.
So now, so how do we count? How do we calculate percentage based on fractions? Actually, I showed you here one way of doing it is that we write an equivalent fraction. That means we make the bottom times 20 on top and bottom. That means if we multiply same thing on top and bottom, 20 divided by 20 is 1. So basically we're timing 2 1/5 by 1. So we didn't change the value, but we change how it's get expressed. So we change expression. So this is 40 out of 100. Good. And we write as 40%. Or good.
Okay.
And so that's how we calculate. It's one way of doing that. Another way of doing that, because a calculator makes things a lot easier. So we basically change that to decimal, then we change decimal to percent. So let's see, what's 40% in decimal? That is 0.4, right?
Yep.
And so 0.12, that's just 12%, right?
Yep.
How about 0.354?
Hello?
Hello?
0.2. Sorry, the audio keeps cutting out, so
Oh,
yeah, so it's kind of choppy over here.
okay. So probably some
only here to
connection
see.
issue. Yeah.
Yeah.
Yeah, I think Morgan, you are okay, right? On your end.
Mm-hmm. Yep.
Okay. Yeah. Yeah, I noticed that once in a while your image got frozen.
Yeah. Yours does too. Like. Hello? Oh.
Hello.
You still there?
Yeah.
Oh, sorry. It froze.
Hmm.
Yeah.
Yeah. So 0.354 is what percent?
354 wouldn't doesn't sound.
Oh, it's actually 35.4%.
Oh.
Good. We just moved the decimal by two. Good.
Oh yeah. Okay. Yeah.
Okay. So when we say 0.4 0.72. We move that by 2, 1, 2. So that's 47%, 47.2%. Good.
Okay. And if it was a 4-digit number, then you would move that by 3 and so forth.
No, still always move by 2.
Oh, okay.
So 1, 2. So that's 52.47%. Good.
Okay.
Okay. So the reason is this. So first of all, what is 0.354? And we can time 100 on top and bottom, right?
What just happened?
Good.
Okay.
So because 100
Yeah.
divided by 100 is just 1, right?
Mhm.
So we didn't change the value, but we're trying to change expression. That's why we play this game. So what is 0.354 times 100?
5.4.
So it will be 35.4, right?
Okay.
Good.
Yep.
Look at here. 0.3 times 10 is 3, right? We move 1 decimal. 0.3 times 100, that's 30. Good.
Okay.
So it's 35.4 over 100, that's 35.4%. Good.
Okay.
So therefore, when you change the decimal to percent, it's actually pretty easy. We just move decimal by 2, the point. Good.
Okay.
Now, when you get 0.3, we still move by 2. That means 1, 2. So we put 0 there. So that is 30%. Good.
Okay.
And so let's say, you might say 1.25. When we change the percentage, that is 125%. Because we move this by 2. Good.
Okay. It doesn't it's kind of confusing for me because percent would mean per 100.
Right.
So it going over 100, that would be,
Yeah, that means something over 100.
yes.
Mhm.
Okay.
It's kind of like when you have a improper fraction, 3 over 2, right?
Mhm.
This is called improper because 3 over 2 is bigger than 1.
Yeah. Oh, okay.
Yeah, so 1.25 is bigger than 1. So we have this percent is just an improper percent, improper fraction.
Okay.
Good.
All right. And when you explained the 0.3, and you moved it over 2 spaces, and you said
Right.
that's also 30%.
30
Why?
because we had to put 0 here because we moved by twice, right?
But how come typically when you explained it last time, it was just 3%?
Well,
And you
if
said you
it's
still move it twice.
0.003, if like that, then move by 2, that's 3%.
Oh, okay.
Good.
All right.
So you always move twice, 2 places. And the reason for that is because this, right? We multiply 100 over 100. So when you times 100 to a decimal, you always just move the decimal point by 2. Good.
Okay. So do you move the decimal point by how many zeros are there? Like when you put an example, 0.3 times 10, that would be 3. And then 0.3 times 100, that would be 30.
Right, exactly.
Okay.
So when you say 0.457 times 1,000, then we just move by 1, 2, 3. So it's 457.
Okay.
Good.
All right.
So that's what we multiply by 10. The reason for that is because we are base 10 system, right? And the decimal used to be called decimal fraction. Good.
Okay.
So 0.3 actually is 310. Good.
Okay.
We just write in this way and make that simpler. Good.
All right. All right. Makes sense now.
Yeah. And the J. Good. Okay, so now we are going to say we actually have a formula to find the percent. The formula is the percent is always part. And sometimes let me see. Sometimes they use R for percent because we're going to use a part here, P for part. Part over whole. Good. So that's our formula.
Oh,
Right? Remember, if we have let's say if you have 10 girls in a class of 20 students, sorry, 25 students. That means 10 girls are part of the class, right?
Mhm.
So to find the percent of girls in the class, we actually do 10 over the whole 25. And that actually is 40%. Good.
Okay.
Are we good on this one?
Yep.
So that's how we calculate percent. But what happens if you know, now we have three symbols here, or three variables. One is a percent, one is a part, and one is a whole, okay?
Okay.
So when you have three variables in an equation, that means if you know any two, you'll find the third, right?
Mhm.
Just like we did last time, we said the speed is distance over time, right?
Yep.
Okay, so knowing that, we are using this formula to find the percentage. But if I gave you the percent and the whole, we can also calculate how many girls in the class, right? Same, come from here. R is P over W. If we want to find the part, how do we find the P? Remember, we just multiply W on both sides. Then this W cancel, then P is R times W, right?
Okay.
So if we know the percent, if we know the whole, then the part basically is 40% times 25. Now, 40% is 0.4 times 25. We'll find that is 10. Good?
Okay.
Makes sense?
Mm-hmm.
And you can also find, if you know the percentage, if you know the part, in this case, 10, we can also figure out the whole, right?
Yep.
How do we do that? We came from the same, remember from that equation, that formula, we got new formula is this, right? Good? From this formula to this formula. So the beginning formula is something called definition. It's how we define the percent. We put a triangle on the top, just indicate this equation is a definition. But based on this definition, we can derive a new formula by playing the symbols. Good?
Okay.
Now, how do we, now we know the rate, we know the part, we need to find the W. So that one we can just, so we got W, R times R is P. So in order to find the W, we have to get rid of R, right? So how do we get rid of R?
Multiply by R. Divide
by R. Very good. We divide by R because of R divided by R is 1, right?
Yep.
So now we got a new formula. The whole is part over R. Now in this case, we know the part is 10. The rate is 40%. Now 40% is the same as 0.4. So we can just use our calculator, and that will give us 25. Good.
Okay.
So the key today, what we are trying to do, because we're trying to play the symbols, is to let, continue with last time we have. Last time we said our speed is distance over time. From that, which is the kind of definition, we know the distance is speed times time. Good. So we got a new formula. Then from that, we'll figure out time actually is distance over speed, right?
Okay.
Good. Are we good on this one?
Yeah, I think so.
Okay, Jay.
Got it.
Okay. So now this time we said the percent is defined as part over whole, and that's our definition. And from that, we derived part is rate times whole. Good.
Okay.
And from that, we can derive our W. W
Next.
is P over R. Good.
Okay.
So that's
P over R.
right. So remember everything we did, even though we don't know what's the value of it, but we still can play with the symbols to come up with new formulas, right?
Mhm.
And that's the power of algebra. Algebra allow us to come with new formulas. Of course, we have to prove it, and the proof is based on our 10 rules, right? We had the rule, we talked about rules before, and the 10 rules of algebra, and also we know there are based on the property of equations. And with those simple rules, then we'll be able to play the symbols based on those rules. Good?
Okay.
For
I only heard half of what you were saying.
what's that?
I'm afraid I only heard half of what you were saying.
Oh, okay. So it's recorded. Probably it's easier when you just watch the recording. Good?
Okay, thanks.
Yeah, but look at the rules we use from here to here. What rule do we use? We actually use this rule. If A is equal to B, then A times C is equal to B times C, right?
Yep.
So we have this. This is a given. We know we can multiply any number on both sides as long as the same. So what we're going to do is multiply W on this side, multiply W on that side. And so on this side, of course, is WR. The other side is P. And when you multiply that, it's the same as W over W, right?
Mhm. Yep.
And we know one of the rules said A times 1 over A, which is A over A, should be 1. Any number divided by itself is 1. So now we have is WR equal to P times 1. And we also know that a number times 1 is number itself. Therefore, P, this just become just P. So P is WR. Good.
Okay.
So far we played the rule. So as long as we follow the rule, we know what we got. The new formula has to be right. Then based on that, we're going to using the same rule again is if A is equal to B, then A times C is to B times C. So we know P is RW, and we can rewrite as WR equal to P, right? Good.
Yep.
Right.
So we are going to times 1 over R on both sides. And that we can do because based on this rule. And we know that 1 over R times R is 1. That's this rule. That's called the reverse property. And then we have 1 times W equal to P over R. And a number times a 1, just number itself. So therefore, W is equal to P over R. Good?
Okay.
So far we just we play the symbols based on rule, but that just if we because we follow a rule and then we are able to come up with new formulas, and that's not the only power, but one of the powers of algebra is that we can play with symbols. We don't really care not the value, because we just play with the formula. We don't know the value yet. But based on just symbols, we can come up with new formulas. And we know we are right because we follow the rules. So once we came up with new formulas, then we can use that in new applications. Good?
Okay.
And that's what actually going to be very useful when you get into pretty much any career that when you're trying to solving problems, and you can, based on what we know, based on the formulas we know, then use the rules of algebra to come up with new formulas. Good.
Okay.
Any question?
No, not for me.
Nope.
Okay. All right. I'll see you after Thanksgiving. Okay.
Okay.
Yeah. So you guys have good Thanksgiving. Okay.
Thank you. Bye.
You too.
Yeah. Bye.
Bye. Thanks.
Bye.